Alright, so today we are going to go over applications of similar triangles. So basically we're going to take what we learned the previous lesson and try to apply them to some more problems, some real life problems. So let's go ahead and get started. So if we come here, just a quick review for your vocabulary. Remember that congruent means that it has the same measurement, an angle has the same measurement. And corresponding means that it's the same position in a different place. So corresponding sides, it's the same side in a different triangle. You'll need to know you'll need that again for today's assignment. Okay, so real quick again, we went over these yesterday, but the AA theorem was if two angles of one triangle are congruent to two angles of another triangle, then they are similar. So you have these written down in your notes already. So we're going to use this theorem today. Then we have the SSS theorem. That's if three sides of one triangle are proportional to three corresponding sides, then once again the triangles are similar. Okay, so that's what the SSS theorem. Then we have the SAS theorem. That's if two sides are proportional to the two corresponding sides, and their corresponding angle are congruent, then the triangles are similar. Okay, so we're just basically going to put these into practice again. So let's look at a couple examples. So first, find the missing length of the following dilated shapes. So it's given that these are similar to each other. So we want to find what is the measurement for the length of y. Alright, to do this we are going to use proportions and be able to cross multiply. So first off, I'm going to use some corresponding sides for the measurements I already have. So here LM is size 10. And its corresponding side is PQ, which is 5. So its ratio, we have 10 to 5. And we're going to set it equal to y and its corresponding side. So we're going to have y on top because I used 10 on top here, over corresponding with y is the 12. Okay, and now I simply just have to cross multiply. So 10 times 12 is 120. 5 times y equals 5y. Divide both sides by 5, and I get 24 equals y. Now some of you have probably thought, well, all I have to do is double it, because 5 times 2 is 10. So 12 times 2 is 24, which you would be correct. So this is one way to do it, or if you can see the simple pattern for how to do it, you could do it that way as well. Alright, so let's find the missing side length of the following dilated shapes. So here we have this guy who's 5 feet tall, who's casting a 7-foot shadow. And here we have this tree, and we want to figure out how tall is the tree that casts a 14-foot shadow. So we're going to just go ahead and make a proportion. So we're going to do 5 over, what corresponding side is 5? Well, it's my x, because it's both the height of something. You're going to set it equal to, since I put 5 on top, I have to use a 7 on top. So we're going to do 7 over 14. Okay, and then we're going to cross multiply. Some of you maybe see, well, 7 times 2 is 14, so 5 times 2 is going to be 10. That's one way to do it, or we can cross multiply. 5 times 14, that gives me 770, sorry. And then x times 7 is 7x. Divide both sides by 7, and we get x equals 10. Okay? And we can do this because we know that they're similar. If they weren't similar, we wouldn't be able to make those assumptions and just be able to cross multiply. So that's why it's so important that we know the theorems that tell us that these are similar by side angle side in this case. Okay, let's do another one. A tower casts a shadow of 88 feet. A 6-foot pole near the tower casts a shadow of 16 feet. How tall is the tower, and what is the scale factor? Okay, so let's go ahead and set up our proportion. So the tower casts a shadow of 88 feet. So we're going to say it's x feet tall, And then, how tall is the pole? The pole is 6 feet tall. Okay. The shadow of the tower is 88 feet. And the shadow of the tower, or the pole, excuse me, is 16. Okay. Then at this point, we're going to go ahead and cross multiply. The hardest part of this assignment is making sure you set it up right. So if you notice, I put my tower measurements both on top, and I put both of the pole measurements on the bottom. You need to make sure you're consistent with where you're putting them, or else it's going to mess up the problem. It's not going to get set up correctly, and you'll get it wrong. So x times 16, that gives me 16x. And then let's do 88 times 6, that gives me 528. So now we're simply going to divide both sides. So let's get a different color. Divide both sides by 16. And I get x equal to 528 divided by 16 is 33. So we know that the tower is 33 feet tall. Alright. Okay, last one. The screen on your old TV is 20 inches wide and 15 inches high. Your new TV is 22.5 inches wide. How tall is your new TV? Okay, so we can create the proportion of how tall the TVs are compared to how wide the TVs are, or you could do the new TV compared to the old TV. There's a couple different ways you can set up your proportion. Let's just go ahead and do the 20 inches wide over the 22.5 inches wide. Set that equal to, since I use the old TV on the top, once again for the height I have to put the old TV on top, and then we want to know how tall the new TV is. So we'll just cross multiply. 20 times x is 20x. 22.5 times 15, let's plug that in. That gets me 337.5. Now we're just going to divide both sides by 20 because the 20 is what's by the x. We get x equals 16.875 inches tall. Okay, so that's how we can use similarity to help us figure out new dimensions and new measurements of certain things. So scale factors are really important to know. I guess on this past one we didn't do the scale factor. So basically, how did I get from 6 to 16? Remember, we do new over old to find the scale factor. In this case, there's not a new and an old shape. We're just going to take the shape we're comparing it to, so the 16, divide it by 6. 16 divided by 6 gives me a scale factor of 2.6 repeated. So that would be my scale factor. Alright, so just go ahead and work on your assignment, and if you have any questions, I will be here you can either email me your questions or you can ask me after school or on Monday. And so just get working on your assignment, and we will see you later.